This is a video for AQA Further Pure Mathematics, Calculus 7.1, Reduction Formulae using Integration by Parts. Well, firstly let's consider this integral, which is the integral of x to the power n multiplied by e to the x. We can integrate that by parts, so that if we take u to be equal to x to the power n, then u dashed will be nx to the power n minus 1. And if we take v dashed to be equal to e to the x, then v is also e to the x. Then integration by parts says that the integral will be equal to x to the power n multiplied by e to the x, that's uv, and then minus n times the integral of x to the power n minus 1 multiplied by e to the x, which is u dashed multiplied by v. Now we can see that the integral that we've got on the right hand side here is similar to the original integral, but it's just that the power has been reduced by 1. So we could call the original integral in, and so this one here would be in minus 1. So we've produced a formula now which says that in must be equal to x to the power n e to the x minus n times in minus 1. And this is what's called a reduction formula. So given a particular integral in, and using integration by parts, we've reduced the complexity of the integral that's on the right hand side. So we've reduced its complexity, and we've shown then that in equal to the integral of x to the power n e to the x can be written as in is equal to x to the power n e to the x minus n times in minus 1. As I say, this is called a reduction formula. Well, now let's use that reduction formula for a specific value, where we've got here n equal to 4. So we're looking at the integral of x to the power 4 e to the x dx. Well, our reduction formula tells us that I4 must be equal to x to the power 4 e to the x minus 4 times I3. But we know that I3 must therefore be equal to x cubed e to the x and then minus 3 I2, and so on. I2 must be x squared e to the x minus 2 I1, and finally I1 must be x e to the x minus I0. Well, I0 will be equal to the integral of x to the power 0, which is 1, and then e to the x dx. Of course, that is equal to e to the x plus constant of integration. Now we can substitute all of those then and arrive at the following, that I to the power 4 is x to the power 4 e to the x minus 4 multiplied by I3, and I3 is x cubed e to the x minus 3I2, but I2 is equal to x squared e to the x minus minus 2i1, and I1 is equal to x e to the x minus I0, which is e to the x plus c. So now we can evaluate what we've got in total. We can factor out e to the x, and then inside the bracket we've got x to the power 4 minus 4 lots of x cubed. The x squared term will be minus 4 multiplied by minus 3, which is plus 12. The x term is then negative 4, negative 3, and negative 2, so giving a total of negative 24x. The number term will be positive 24. And then we can write outside the bracket a constant of integration, k. So let's just look through that again. Our reduction formula was In is equal to x to the power n e to the x minus n I n minus 1. So going through that in turn from I4 all the way through to I0, we found these different expressions which could all then be substituted back into the first one, I4 in turn, and then taking out from that a factor e to the x. Well, that concludes this video on reduction formulae. In the next form we'll look at reduction formulae using identities.